Alright, we're back with equation student handout number 7. This unit is a little bit longer than any other one, but it's okay. This is titled, Is Everything Equal? This is by far probably one of the most easiest things I think is to do, but fun to do. It shouldn't be too much confusion. It's kind of combining everything we learned together, but actually you get to learn this new trick on how to actually visualize your inequalities. We talked about inequalities with integers greater than, less than, last time, but now we're going to learn a new sign that you guys may not have been exposed to. So at the top part, we're going to start always out with our sentences, and it says an equation uses an equal sign to show that both sides are equal. We know that. And an inequality shows that both sides are not equal. So this is where the inequalities, you're going to learn the signs that show that they're not going to be equal. We know greater than, less than, and equal to, but what if they're not equal to? And what if they have other different rules, all right? So to start off with, to show the greater than sign, so my example I'm going to do is 8 is greater than 7, right? You know, you're eating the bigger number. Most of you guys know that. But now this one is new right here. Greater than or equal to. Now you still have the same numbers, but the sign greater than or equal to has the greater than sign but a line under it. That lets me know that 8 is greater than or equal to 7. Okay? So less than sign, we know that, so we're going to say 5 is less than 7. And this one's a new one right here. And it says less than or equal to, same thing. 5 is less than or equal to 7. So if it was equal to 7, that means that number would be 7. So 7 is less than or equal to 7. All right? And not equal. 5, this is also a new one, does not equal 7. That equal sign with a slash in it tells me that it is not equal at all. So those three at the top are the only new ones. It's basically the same sign with the line under it. And when it's not equal, it's an equal sign with a slash into it. All right, so let's do the ones right here. And our next one, 4 and 9. 4 is less than 9. Nothing too simple. Nothing too hard. Sorry. And it says 0.5 and 0.45. 0.5 is greater, so it needs to be always eating the greater one. -3 and -2. Remember, the lower the negative number is, the closer it is to 0. So if I'm going to eat the bigger number, -2 is greater than that -3. So, but -3 is less than -2. All right, nothing to trick you up right there. Now it says these statements can be read two ways. So it says 6, if we go back to look at that, that's 6 is less than or equal to x. So that means 6 is less than or equal to x. And on this side, this says y is less than 0.5. Do you see how the variable is at the end on this side? Because it says 6 is less than or equal to x, and this one says y is less than 0.5. Okay, so moving down a little bit further, that blank sentence right there says use the variable as the starting point when reading inequalities. All right. It's easier to understand when the variable on his left, right? We can read this one because y is less than 0.5, but this one is not on the left, so it's harder to read. So in essence, if we had to flip it, it would be x is greater than or equal to 6 if you had to reverse it. But when the variable is on the left, it is much easier to read. So these 9 problems on the bottom, we have to determine. I'm going to come in. You have to determine whether values make a true statement. Okay, so you have to determine if it makes a true statement. So I'm gonna go ahead and start with this one. It says, I'm gonna see if you guys can see in pencil. So if I make a mistake, I can erase it. It says k plus 8 is greater than or equal to 19. And now it says k equals 11. Remember how we always exchange the letter with the number. So now let's rewrite it because k equals 11. So wherever you see k, put 11. So you have 11 plus 18 is greater than or equal to 19. That's what you will now see. Oh, sorry, that's not 18. See, that's exactly why I use a pencil. That's 8. 11 plus 8 is greater than or equal to 19. So when you add 11 plus 8, you get 19 greater than or equal to 19. Is 19 greater than or equal to 19? Yes. 19 is equal to 19, and that is true. All right. Number 2, it says 12 is greater than f when f equals 3. So we're going to replace f with 3. So we have 12 is greater than 3. Is 12 greater than 3? Yes, that is true. I'm going to do 3 and 4, and you're going to do 5, 6, 7, 8, and 9. All right, number 3 over here, we have 3 is greater than d when d equals 3. So we're going to replace that d right here with the number 3. So it means 3 is greater than 3. Now, is that true? Is 3 greater than 3? No, that is false. If it had the equal to sign under it, then it will be true, but it did not. All right, and 4 says c minus 12 is greater than 30 when c equals 13. So I'm going to place 13 right there, minus 12 is greater than 30. Now 13 minus 12 is 1. Keep my same sign in that number. Is 1 greater than 30? No, that is false. So you guys go ahead, do 5, 6, 7, 8, and 9, pause it and come back to it, and we'll go over it. All right. For number 5, you have 16 is less than b minus 8 when b is 22. So rewrite your sentence with the b in there, and b now is 22 minus 8. You need to solve what is 22 minus 8, and when you get 22 minus 8, let's see, Miss Scott, brain is not functioning. It's 14. So is 16 less than 14? No, that is false. Number 6, when you work this one out on the side, it says 6x plus 5 is less than 18, but x is 5. So plug in x. Remember, when you see it beside each other, you multiply. So when you plug in that 5, you have to multiply them together. So it's 6 plus 5 right there. Now you need to solve it out. 6 times 5 is 30, plus 5 is 35. Less than 18. Is 35 less than 18? No, this is also false. Okay, so far so good, nothing too complicated. Number 7 says 2j is less than or equal to 8 when j is 5. So go ahead and plug in 5 for j. The numbers are beside each other, so you multiply. All right, so I know that 2 times 5 is 10. All right, is 10 less than or equal to 8? No, that is false. Maybe we can get some truths in. Number 8, we have 5r minus 3 is greater than or equal to 25 when r equals 6. So plug in 6 where you see it, r. So you have 5, 6 minus 3 greater than or equal to 25. Now you have 5 times 6, which is 30. And I know that 30 minus 3 is 27. And that sign was greater than or equal to 25. Is 27 greater than or equal to 25? Yes. This one is true. And number 9 over here, it says 6m minus 12 is less than 40 when m equals 8. So I'm going to plug in that 8 right there. All right. I know that 6 times 8 is 48. And 48 minus 12 is 36. Is 36 less than 40? Yes, that is true. Okay, so just in a sense, we're still doing what we've been doing. You're substituting that letter for a number, plugging it in, and all there is, instead of an equal sign, we have the greater than, less than, and equal to sign to work with. Okay, so pause if you need to catch up, or we're just going to go ahead and flip on the back side. I'll pull this up. All right. It says inequalities can also be graphed on the number line. Bringing back the number lines. All right, so here's the two things you're going to learn. There's a closed circle and there is a open circle. Now, the closed one is the symbol that we saw on the back side that had the bar under it. So the ones that look like this when you graph it. The ones that are not included are these two. So it's an open circle if it's just less than or greater than. It's a closed circle when it's less than or equal to or greater than or equal to. All right, so let's look at this example. It says x is less than or equal to 5. So we know that this sign makes this circle going to be closed. So what this will look like is you're going to go to 5, right? And then you're going to put a closed circle. And you are going to go make an arrow this way. Because you are saying that x is less than or equal to 5. That means that x can be 5, but it's going to be less than. So that's why you're dragging this arrow to the left side, because that means any number less than it. This tells us which direction to go. This says less than. Now, if this was greater than, we will go the other way. But this says less than. All right, we're going to practice graphing these. Number 10, 11, and 12, I'm going to do with you. 13, 14, 15, I want you guys to do by yourself. All right, for number 10, it says that K is greater than 11. So I'm looking back at my chart. This one doesn't have a line under it, so the circle is going to be open. So go to 11. I'm going to have an open circle. Now it says K is greater than 11. So if it's greater than, my arrow is pointing that way. And that's it. Number 11. 12 is greater than or equal to F. So I'm going to go to 12 and I need to look at the middle, see if it's open or closed. It's closed because it has the bar under it. So I'm going to have a closed circle. Now it says 12 is going to be greater than or equal to F. So here is where you're going to have to flip your mind. All right, because you remember on the back side, it is easier to graph inequalities when the variable is on the left. This one has the variable on the left side. This one is on the right side. So in order to graph this correctly, you need to flip it. And when you flip it, everything flips. So now you have F, flip the whole sign. It was greater than, now it's less than or equal to 12. You have to do this when you have the variable on the right side. You have to flip the whole entire problem. So now it says F is less than or equal to 12, and this is less than, so it is going this way. Sorry, 12. D is less than 6. This variable is already on the left side, so we're good. So this one is going to be an open circle. So I'm going to make an open circle at 6. It says D is less than 6. Less than is going this way, and that's where my arrow goes. All right, pause the video. I got to go check on my lemon bars, and we'll do 13, 14, and 15. Okay, we're good to go. Now, for 13, when you've graphed this one, you have C is less than 25. I see that that's going to be an open one. And it says C is less than. So you are going this way. If you graph that correctly, that's what you should have gotten. All right. For 14, it says 0 is less than or equal to B. But let's go ahead and flip this over because your variable has to be on the left side. All right, so now you have B, flip the sign the other way, and there you go. So I know that this is going to be closed because that equal sign under it. Now it says B is greater than or equal to 0, and it's going this way. 15 says X is greater than or equal to 4.5. I know my circle's going to be closed. Now 4.5 isn't listed on here, but it's in between the 4 and the 5. It's going to be closed, and it says that it's greater than or equal to, and it's going this way. And that was all to it, to graph an inequality on a number line. Now on the bottom, let's see if I can pull it. Sorry guys, I want to make sure you guys can see. All right, there we go. It says based on each of the verbal expressions below, write and graph the inequality. All right, it says the McDonald family spends no more than $150 for groceries each week. So your variable is always going to be on your left. We're going to start with it. So it says they spend no more than $150. Can they spend $150? Yes, but they can't spend no more. So that lets you know that it can be $150, which means that it's either less or equal to $150. All right. That no more than lets you know that it's this type of sign. If it says that they spend less than $150, then it will just be the less than sign without the equal to. Now, when you're graphing it, this is where you got to be careful on how you're going to scale it, okay? So if you know that you're going to be talking about something less than, that means you need to have your number at least somewhere in this area so you have enough to make your line. So I'm going to count by 10, start with 110, 120, 130, 140, 150. All right? So I know that my circle is going to be closed. And that sign is less than, and that means that way. All right, you don't have to do it this way, but you just need to make sure you don't want 150 right there. You want at least to make it known that you're going less than. On the other side, you have Gerard earns at least $10 per hour when mowing lawns. Again, this key word, at least 10. Can he earn 10? Yes. So that means he can earn more than 10. He makes at least 10. So he doesn't make 9, he doesn't make 8, he makes 10, at least 10. So we start with a variable, x. Now, if he makes at least 10, that means he can make more than 10. So x has to be greater than or equal to 10. All right, and we're making our number line. You can do it however way you want. I'm going to label this one by 5. So 5, 10, 15, 20, 25. And when I graph this one, I know that it's going to be closed at my 10. It says greater than or equal to, and there you go. This way. All right, so that's all to graphing. You just need to know when to open it and when to close it and which direction to go. All right, go ahead, summarize today's lesson at the bottom. 1 to 2 sentences. Make sure you guys are doing that. I'm going to go ahead and pull up your homework to see if you may have any questions. If so, I can help you. So you would be on homework number 5, which looks like this. Right here. So it says, is everything equal? Remember, same title, same notes. It says substitute each variable. We did that part right there where all you're doing is taking that number 15, plugging it in, see if it's true or not. True or false, basically. All right, and the next part right here says graph the inequality that shows what it is. So it already graphs it for you. If you see it, there's a closed circle going to the left. So you remember your variable goes first on the left side. So for number 4, it will be x is less than or equal to 11. So I already gave you an answer. It's a closed circle, so I know that it's going to be that equal sign under it. So this one would be x is less than or equal to 11. So you're going to go ahead and do these next two. Remember, just because it's in between 10 and 11, you know that right there is 10 and a half, okay? So 4, 5, and 6 are easy. And then you're going to graph 3 of them. So we just finished doing that. Make sure you change this one. Remember, the variable's on the right side. You need to flip it. Flip the whole thing over. Sorry, guys. Flip that whole thing over so your F is on the left side, and you have to flip the sign too. All right? Nothing too hard. And 10 and 11, the same thing that we just did. Taking that verbal expression and solving it. So if you have any questions, let me know.